Okay, I want to briefly introduce you some information about the foundations. Of course, next week we talk about the foundations actually part. It involves sharp impressions, form and bearing capacity in clay, in sand. Before that, we want better to know about some information. Before that, we have prerequisite knowledges. Three topics: effective stress, shear strength, consolidations. These are our pipes. And then our soil confining our pipes, skin frictions, and end bearing, right? These confining pressures mostly coming from our effective stress. Our soil's self weights press down our soil and ground, and then that effect improves our bearing capacity. That's why we are able to calculate effective stress. This is a 3 meter, right? And then unit weight is 15 kilonewton per cubic meters times depth. So this is 3 meters, cancel out things, and then this unit became kilopascal. This amount of kilopascal pressure confining our pipe plus 4 meter times 17, again confining our pipe. From here to here, I don't know. We are supposed to determine its remaining length times 19. These combined pressures improve our bearing capacity. That's why effective stress is needed to calculate our bearing capacity. Of course, our shear strength. Tau equals to C prime sigma tangent phi. C phi equal pi is our shear strength according to Mach-Lung circles. And then why do we need the consolidation settlements? Soil settlement means pipe settlement. Sometimes our clay layer settle faster than pipe settlements. It means we will experience negative conditions. That's why these three concepts is fundamental knowledges to study our foundation engineering. How many times I speak bearing capacity? Can't count. So what is the bearing capacity? Contact pressure between pipe and soils. Soil pressure to support our foundation system without shear failure. What is the ultimate? Same pressure, maximum pressures right before soil fail in shear. Why? What is shear failure? Very common failure mode in soil. Slope. This is also shear failure. Shallow foundation, failure mode, also slip failure, which is shear failure. Cantilever, shear failure. Tunneling, also shear failures. Even pavements. You tested your asphalt concrete, right? In transportation engineering modules. The tire roads cause shear failures. good examples.
This is an example of a retaining wall failure, a familiar hazard in ground engineering. An engineer designed a wall to hold the dry, sandy soil whilst houses have been built above. Examples of this can be seen where roads or railways or other excavations have been built that cut into the land. Unfortunately, this wall has not been designed correctly and has started to fail. This slope failure is translational in nature, and you can see the slip planes that have formed. Slope failures in wet clays and silts tend to fail at shallow angles and be of a rotational or flow type failure.
Pro, this Tower of Pisa also shear failure. These blue layers, upper clay, forest clay is quite problematic. Singapore marine clay, much more problem. Why? That volume increase and decrease when water infiltrates. I can see you why Tower of Pisa tips.
Here we can see the effect of a clay swelling due to water ingress and the subsequent damage to the house above. This hazard is known as heave and is associated with the shrinking and swelling properties of clays. This tends to be a problem in areas of dry climate subject to occasional heavy rain. You can see here that as the clay gets wetter, it swells and pushes the ground above it upwards, damaging the house. Shrinkage of clay, the opposite process, tends to be more dominant in wetter climate subject to occasional prolonged dry spells.
Pulling up and then we force the house to go back to original place. This is the way the Tower of Pisa is being recovered. Tilted. Wow. This one is tilted. This is low, this is high. And then we drill a hole and then remove some part of soils. Then while removing the soil, the wire resists this hole, this Tower of Pisa to protect 100% collapse. Then gradually go back to the original place. The initial degree of is 5.5. Then now it's around 4. Constant stable conditions. Can you recognize this building?
Yes, I think it's a Samsung Hub, right?
Yes. Near Telagaya.
Yeah, I see.
Only 30-story building. Yeah, it's considered a high rise, but typical height, right?
Yeah, this is a Samsung Hub.
Yeah, of course, Samsung, the company, is building this. But we have some issue. Six parts were not socketed 5 meters into the rock. Because Singapore mostly recommend your pile should be socketed in pile. Sorry, socketed in rock. But majority is still floating. And then we have severe deformations. What is our recommendations? The criteria for your formative assessment, pile settlements, only 15 mm. Now, 164 mm, even 70 mm. BCA. Hey, stop. What happened? So finally, we have 0.1 degree tip. Concepts cause some cracks in buildings. It took 2 years to the rectification work. reinforce on the pin some micropile, inject the grout. First of all, why it has happened? Inadequate soil investigation, site investigation. Of course, some core here, there are two boreholes. But in between these soils, we can't imagine, we didn't know what has happened underneath. Your kisojiban activities, site investigations, that activity is very important. You invest more borehole, finally end up with having more profits. Before talking about what types of pile do we have, Portland cement, so-called cement paste, invented. Then after that, reinforced concrete. We insert our rebar into the cement paste and then cure it, which is the reinforced concrete. Invented. Then after that, prefabricate certain reinforced concrete. The shape is circular and then long. Then this is our pile. Sometimes we can call it caps of concrete, or we can so called board pile. Cure it in place. We appreciate such brilliant inventions. So our piles can be divided into three with respect to material, installation method, effect of installations. Of course, concrete, number one pile. Steel, also number one pile. Timber, also number one. Concrete, 10 years back. The timber pile, yeah, we frequently use. But now only exterior walls. The interior, the sports hall, the all exterior is made by wood materials. So very recently, recent year, fourth industrial revolution era, we only use concrete and steel. It doesn't matter our shape, circular, different shape, even eye shape. Mostly we use concrete and steel pipe. Very old, outdated. Concrete, different grade, different bearing capacity. Even higher building, we should go with higher concrete strength. This is the compressive strength, right? 40 megapascal. And sometimes we have circular concrete pipes, and then different shape and prefabricated pipes, RC pipe. What about the steel? Oh, have you seen H pipe? Consider our individual pipes inserted ground to support our buildings, as well as this one is the H pipe for retaining wall. Very famous in Korea. This one. Of course, Singapore mostly we design the wall, right? Have you heard about the wall? The most common retaining system, because Singapore soil condition is not that good. So we need to secure the very safe space. That's why Singapore always go with the wall, diaphragm wall. But in Korea, sometimes we face rock in a very shallow. That's why this H pile and then wooden materials still good enough to resist earth pressure coming from behind. And then circular steel pipe, very common. What is that? More than 2 meters. My height is around 2 meters. No, 107 something. More than that, my height, diameters, 80 meter, 100 meter long. In offshore, for wind turbine. We must go with steel pipe because steel materials much stronger than concrete. Even compression and tension. Why the researchers came up with RC concrete, reinforced concrete stronger? Why? Yeah, concrete very weak in tension. The river resists tension. But this steel part, this one is very strong in compression and tension. Yeah. When you hit, this one is the compression, this one is the tension. Earthquake. Steel part sometimes very strong, so go-to materials in terms of high expected loading conditions. One of the big advantages of using steel pipe is weldability. We can connect them with weld. Very easy to handle. And then we can classify our pipe by method of installations. Mention to you, this is the pipe. Hit, and then pipe installed. Driven, hammer, or pipe, flip over, and then simply inserts. Very gentle pipe, which is board pipe. In Singapore, only 2 cases, even worldwide. Driven board. Even each pipe can be driven into the soils by generating vibrating and impact force. This is the pipe driven lift. And it's a hammer. Delma and Burton hammers, very famous hammers. Let's see some video clips for the driven pipes. This is the concrete pipes. Yeah. When you driven your pipe, probably need adjacent the pipe soils tend to move regularly, right? This side, this side, this side. Then around the soil can be disturbed. Observe my hand. When we have the sand material around here, probably it will be densified, right? Some dynamic force. And then soil particles, the porosity, moving, getting decreased and decreased due to the impacting force. And then when it comes to clay, it's an all amount clay. And you keep your pipes. Probably excessive water pressure will generate it. Right? Higher export pressures, lower effective stress. Low effective stress meaning low shear strength. Sometimes this the activity of the hammering is good for soil, sometimes quite negative for soils. So considering the ground conditions and then shape of the pile, material of the pile, we decide the construction method. Wow, very bad. Break already. Broken already. Wow, already cutting already. During the heating. Be careful. Wow. Can you imagine how heavy the hammering rope is? Wow, cramped. Still steam. Without stroke. Still. So like that. Break already and then broken already. Another type is bow pile. Drill a hole, fully drilling. Then in case you can extend the pile base, and then set your staircase, and then pour in your concrete. Very famous in Singapore. Most of the construction methods go with bow pile. This is the fully drilling machines. The screw, and then this is the board pile cage. After boring, we put into the hole, and then pouring concrete. Different lengths, different. I mean, right after our pouring, the curing the board pile, we cut it out and then level them with all the same heights. But we have certain issue in the board part. Drill a hole, and then put our cage and pour in concrete. In the meantime, sometimes the weak soils collapse. Wow, our initial pile diameter is 1 meter. After collapse, only 0.2. Very dangerous situations. The stress concentrations will be expected. So after pouring mass concrete, curing the concrete, then we can do some integrity tests and then check mass or volume we plot. Okay. Then we can calculate the concrete volume, then compare them. Whether our design concrete volume placed in the this borehole. So the placement of concrete should be done. This training pipe does not lift above the concrete during the process. This is a training pipe. The concrete coming out from this pipe, and then this is the bore. Then we pour concrete, and then everything is filled in the space. Then lift up our training pipe. This is actually depends on the site engineer workmanships. That's why your role, your consultant firm, your main contractors, you go down to the site, check this process, and then check your concrete volume. At the end, you do the integrity test. So we use the standard augers, the pouring bucket, the scissors, percussion drilling. Every method can be available to do some pre-bore. Okay, let's take a look the bore pile construction. Sometimes we dedicate this spacing. It means
Steel material is sometimes very expensive. Mainly we reuse the steel casing. I have another video for Gopal. Okay, just better to read off the advantages of Wi-Fi and disadvantages. Mostly we highlight advantages. Low vibrations. That's why cause low soil disturbance. It means non-displacement high. The third pi classification can be done by effect of the installation.
driven pipes causes significant soil disturbance, which is displacement pipe. The bore pipe, we drill a hole and then just simply put our cage and then cure it. Non-displacement pipes. Can you imagine enclosed pipe? And then we insert it. Probably causes very huge vibrations. It may cause significant disturbance, large movement of the soils near the pond. And then what about the H pipe and then circular steel pipe? Relatively less. And then bore pipe. Totally non-displacement pipe. Advantages and disadvantages. Non-displacement pipe. The most important thing is a driven pipe, is a bore pipe. The area is a compacted area. Probably this soil can be densified, sometimes very weakened areas. So should affect our bearing capacity. This is the unexpected bearing capacity. That's why after your preliminary design, we're gonna do pilot test. BCA, LTA, right? The criteria. You have to do pilot test. Two criteria. Strengths and settlements. And site investigation is more important. Okay. Now it's time to answer the first part piece. Can you remember that our Hampton Hall building 66 pipes couldn't be in block. It means initial design expected lock socketed pipe. It means expect high end bearing capacity. But improper soil investigations, well, majority is the only friction. That's why Singapore government local codes set another rule. Check shock resistance only. That's why the majority of the load transfer pipe is end bearing only and end bearing plus skin friction. Most of the Singapore engineers think about only for skin friction only pipes. This is the conservative design. So, please go back your Excite and then navigate to quiz. Open 1 minute quiz. Quick eight. Only 2 questions. And then it is now ready. You already. Okay, good. Answer. What is the most common friction? Because normally we expect back perspective. It means high end bearing capacity, but due to lack of the site investigation reports, sometimes we lost our end bearing capacity. That's why we only consider shaft friction only. Of course, we consider end bearing and skin friction, but at the end, we check shaft friction only. That's why most